In today's video, we are diving into an incredible robotics project by Manuel Schweiger. He successfully integrated the quadruped robot Spot into a simulation workflow using Isaac Sim, reinforcement learning, ROS2, and cutting-edge vision language models. By combining these technologies, Manuel built an AI-driven agent capable of reasoning in complex warehouse environments, detecting objects, evaluating hazards, even suggesting actions. This is the part 1, where we will explore the full simulation setup, from training Spot's locomotion policy in Isaac Lab to setting up cameras, ROS2 integration, and connecting everything to a vision language model on a Jetson platform. In part 2, Manu will take us beyond the virtual world, showing the real Spot robot in action, complete with its arm, performing real-time object pickup with just a single prompt command. We will break down every technical detail, step by step, and show you how the system was built from the ground up. So without further ado, let's jump into the video. So hi Manuel, thank you so much for coming. Yeah, how about you present yourself and then your project?
Yeah, so my name is Manuel. I've been doing robotics for a while now, and today I'm going to show you an implementation with Isaac Sim and a quadruped robot simulated in Isaac Sim and feeding its camera frames into ROS2, using it as a middleware for a perception pipeline in this case. So on the screen, you can see on the left Spot with arm simulated, and on the right viewport in Isaac Sim, you can see a banana and a electric power drill. And this camera feed here is published into ROS2 with OmniGraph. As a next step, we can utilize N8N, which is a tool to build AI agents, for example. And in this case, I built a ROS2 agent to interact with robots and VLMs and a LLM. So in this case, we can ask the robot or the agent. Actually, we are asking the agent if it's detecting, for example, a tripping hazard with the robot, which we have seen in simulation here. So, for example, does SCAR see any tripping hazards? I typed here SCAR. SCAR is the name of the robot. It's in Lion King theme, so I'm naming my robots in Lion King theme. And yeah, this one is named SCAR. So what is happening here? The agent is detecting ROS2 topics. It's using various tools to get the data from ROS2. And there is a ROS2 Web Interface in between so that we're able to interact with ROS2 data via HTTP. So this is the setup. And as you can see here now, it called actually, okay, ROS2, give me the data of the robot SCAR. Then the data is published to the ROS2 agent, and the agent is calling the VLM here to perform some analysis, for example, to ask the VLM, does the robot see any tripping hazards? And the nice thing about it is I don't have to ask, do you see a banana? Do you see a power drill on the floor? The VLM is using its reasoning capabilities to understand, okay, a banana on the floor would mean it's a tripping hazard. So probably this is an output which we're going to see in a few seconds. The VLM is deployed on a Nvidia AGX Orin with 64 gigs of RAM, which is a development device from Nvidia to do AI and robotics projects. And yeah, in a few seconds, we're going to see the result of the agent. It takes some time because it's in a complete distributed network happening here. So it's not everything on my local development machine. The robot is simulated on my local Isaac Sim, but the AGX is somewhere else, and it's everything connected via ROS2 within a VPN. So all the data transmission and stuff like that takes some time. We've got the result now from the robot Scar. It detected a banana lying on the floor, partially obstructing the walkway. We also got the bounding box for it, which is pretty cool because we can do on top of that manipulation tasks, for example, so we can ask the robot pick it up and place it somewhere else. But this is going to be another video. And it also detected some orange object scattered on the floor. So it didn't properly detect the power drill at the moment, but it detected it as a tripping hazard, which is quite fine. So it recommends me to clean up the banana and the scattered tools to prevent tripping in this case. And this is everything done by the AI agent. It's also seeing some wood pellets with the front right camera within the warehouse environment. And it also tells me, okay, a wood pellet could be a tripping hazard in this case. And yeah, it's giving me some overall safety recommendations, how to maintain a clean environment without any potential obstructions and hazards in it.
Very cool. This project is so awesome. And like you've mentioned, like no model has been specifically trained to detect a banana or drill, right?
Exactly. So the cool thing about it here, I'm using a Quen25 VL with 32B parameters. It's quantized and it's running on a 64 gigs AGX Orin, which is pretty awesome. And it's capable of a lot of things which are very useful for robotics applications. And yeah, as we saw here, I didn't have to ask it specifically for detect me a banana, detect me a power drill or whatever. I'm just asking it, do you see any tripping hazard? Do you see an open manhole, for example, which could be also a hazard? So those reasoning capabilities of the VLMs, there are several other VLMs like Gemma 3, which is pretty good at this, or Gemini 2.5 Flash. I tested this also. So there are several other options you can use for those perception tasks, but in this case, Quen 2.5 was showed me pretty good results.
Cool. Awesome. Yeah, so I have already had the privilege to see the second part of this project, so which will be the real part. So maybe you can already tease the people what they can expect in like another video, because this project is not just in simulation, it is actually being deployed in the real world and on a real spot. So yeah, maybe you can tell them more about that.
Yeah, sure. So what we saw here is my AI agent, which is a bit trained to be looking for safety hazards like tripping or any obstructions or obstacles within the robot's pathway. So when I'm asking the agent, does robot Scar or whatever robot we are using see any hazards? The agent is also able to call ROS2 services and actions, which then are able to do manipulation tasks like picking up the banana or picking up the power drill and put it into some storage container, for example. So this is part of the next video. This is already, I have been doing this already in real with our real robots. It's not yet implemented in simulation, but yes, this is part of the next video.
Oh, very cool. I'm very excited for that as well. So yeah, maybe let's dive into some technical questions so everyone can learn like how you created this project. So like you've mentioned, you have used Isaac Sim, as we can see right here, which is capable of a lot of stuff. And you are using a reinforcement learning policy but you have not trained it in Isaac Sim, but instead, of course, Isaac Lab, which is meant for reinforcement learning tasks. Can you tell us a bit maybe more about how you trained it, maybe how many environments, how long it took, the rewards functions, etc.?
Yeah, sure. So yes, as you said, trained it in Isaac Lab, which is built on top of it. And in this case, I took the public example from Nvidia and Boston Dynamics as a baseline, where they utilized RSL, RL, PPOs algorithm, which is a optimized PPO algorithm, doing pretty well and fast computations on GPU. So this is what I took as a starter. Difference here is I didn't train the robot the normal spot. I used the robot with ARM in this case. So I had to change the model a bit. I added some cameras to the model, and yeah, then I started training with RSLRL. I configured it to have 20,000 iterations in 4,096 environments. And yeah, I did the training on a Nvidia T4 running on Microsoft Azure. So the training was running in the cloud. It took about 18 or 17 hours, something like that. And as soon as the training was finished, I just downloaded the weights and the model, played the policy, and just did a check if everything is behaving like it should. Maybe what I can show here is when the robot is moving it around. So I'm moving it around with my keyboard at the moment. You can see the arm is doing some jerky movements here. The reason for this is I didn't yet properly define the reward function to penalize unnecessary arm movements. So one solution could be defining a stow position of the arm, and in every step, the arm is moved unnecessary, it's going to be penalized.
So the reward function that you have trained is basically just for the robot to have any types of inputs, like to the left, right, or any type of force, and just to be able to stand, right, and to balance itself.
Exactly. So the train policy here is just focusing on the robot's locomotion, trying not to fall on a flat environment.
Yeah, very cool. And next up, after you have trained the policy, you have set up the environment in Isaac Sim.
Exactly. So what I did here is I created a Isaac Sim standalone application. I added the warehouse environment as a basis here. I added the robot and the robot's policy with it, so that the robot can be controlled in the application. So I can use my keyboard to control and move around the robot. And then I had to add the OmniGraph scripting to be able to publish the robot's camera feed.
Yeah, Isaac Sim has a ROS integration. There are multiple ways to integrate ROS. One would be the OmniGraph that you have mentioned, right? Is this what you used, like connecting the graph yourself, or how did you implement ROS here?
Yes, exactly. So first, I tried it with a different approach. So I used the camera API of Omniverse Isaac Sim, which is also a possible solution to get data, and just use RCLPY and create a ROS2 publisher from scratch. And then you can also feed the camera frames into ROS2. But as Isaac Sim already provides out-of-the-box OmniGraph and a ROS2 bridge, I used that in the end, which is basically taking the camera's feed. You can set width and height of the image. You can set the hertz, how many frames should be published per second, for example. So you can configure a lot out of the box. And this is pretty cool, and this is what I used here.
Now, talking about ROS2, can you maybe tell us a bit more about the exact workflow and what topics, for example, you have used?
Yeah, sure. So usually, Isaac Sim only supports the standard middleverse of ROS2 and not Seno. But for real projects, I have been using Seno for a while now. So that's why I started using Seno as well here, though it's not supported, but it's working as you can see. So I'm gonna push here a bit. To get it into support. One major thing is here that you can only use ROS2 Humble. And I created the OmniGraph script in the model. So I configured the ROS2 topics, for example, the name of the robot, the camera name, and then the image. So those are the ROS2 topics which are generated by Isaac Sim, and they are visible within the ROS2 system here in this case. So in this case, I can show it for a second in my terminal. If you want to see it, we can show the topics here. So this is the ROS2 Web Interface, which is telling me, okay, we have a topic called SCAR, camera front right image, which is type of sensor image, message image, which are the standard images of ROS2, and also front left. And these are exactly those frames which you can see here in my right viewport.
I'm curious about how you now connected the ROS2 with the N8N system, and if you needed something else to connect this.
So usually ROS2 is not running within the web, and N8N is. So I needed to create a interface between N8N and ROS2. One option could have been creating a MCP server, for example, which directly translates ROS2 to MCP, which can then be utilized by N8N. But my choice here was creating a ROS2 Web Interface, which translates ROS2 to HTTP. It's a bit more versatile, and you can use it with a lot of systems. So it's not necessarily tied to an AI application. You can use it with something else as well. So yeah, this is what was needed here. And with my ROS2 web interface, N8N is able to interact with ROS2 topics and ROS2 data.
If you don't mind, could you open the N8N AI agent or AI agents rather?
Sure.
Again, and maybe walk us through
Yes, sure.
how that happens.
Yes, sure. So what you can see here, an AI agent usually consists of just multiple tools and functions being called in a row or simultaneously. So this is what's happening here. So we've got a Azure OpenAI chat model connected here, and also those ROS2 tools. And those tools are called by the AI agent depending on what we are asking it. So if we just ask the AI agent what's the robot's battery state, then it's probably not gonna call an image topic. It's just calling the battery states topic, for example, getting the data and feeding it back to the end user, for example. You can also see here the action tool, which is used to execute ROS2 actions like picking up objects, placing them somewhere, for example. And yeah, so this is what's happening here.
Yes, and out of curiosity, it would be probably possible to take these actions and feed them back in a loop. So it's kind of like doing multiple tasks, maybe in a row.
Exactly. So what I'm doing here is It's a request response model. So the agent is executing a request and it's getting a response back from the ROS2 Web Interface. So it's, for example, it's calling on the pick action here. And as soon as the robot was able to grasp the object and is in its carry position, it's reporting back to the agent, hey, I've got the object. The robot is not holding it. And then the agent knows, oh, okay, now I can, for example, look for the storage container to place the object into it.
Cool. And do you think it's possible to see maybe a live demo of another object that you place in Isaac Sim today?
Sure. Yes. We can do, what can we do? What do you like? A cup?
Yeah,
Let's
like
do the
cups.
mug
Yeah,
here.
yeah, very dangerous in a warehouse.
That looks good, right? This looks like a really dangerous warehouse with these bananas here. Um, and now we can do again. Does Scar see any other? What should we ask it? Should we ask again for a tripping hazard, or should we ask it for, I don't know, any other objects on the floor? All right, so what init or ROS2 see in this case is my right viewport. It's seeing the front left fisheye camera and the front right fisheye camera. So init and the VLM, which is executing in the back of it, is gonna see those frames on the right. You can see here the cup is probably detected, the banana, the pallet here, which could also be a tripping hazard. And on the front left, it's probably detecting an object on the floor. Maybe it's detecting it as a drill, I don't know. Let's see. And yes, this is what ROS2 and init is here seeing. Let us get back. So it's going to take some time because it's a huge model here. And it's transmitting over a huge VPN. We've got the result here. It's already building the result together. So what it's got here, it detected a tool, Origin Black, which is probably the power drill here. It's also giving me the bounding box for it. On its front right camera, it's detecting a yellow banana and a red coffee mug here, and also included the bounding boxes so I can issue now pick and place actions, for example. We've got some safety recommendations of the agent as well. Okay, remove those tools and objects because the tools, I guess it's meaning the electric drill here should be collected and stored properly to prevent any tripping hazards. And it's telling me, okay, please clean up your work environment and organize this area. So yes, that's pretty cool.
Yeah, super impressive. I think a very important question to a lot of viewers out there would be, is this open source? And can they collaborate or maybe help you on this project?
Yes, sure. So I'm super happy about any contributions on my open source repos. My ROS2 web interface is open source, is heavily under development, so I'm doing a lot here. So expect some changes, expect some bugs as well. But I'm doing a lot here. My Isaac Sim standalone application is also open source as well, and Isaac Lab and the other tools are anyway. init is open source, and Isaac Lab as well. So yes, everything is open to contributions, and yes, let me know if you find anything and if you have any ideas what we can integrate more and features to add.
Well, thank you so much for showcasing this, creating this project, and then also, letting everyone be part of it and use it as open source. I think that's very generous and very cool from you. So thank you so much.
happy to. Thanks for the video and showcasing of it. And I'm looking forward to the next video showing manipulation and the real part of the sim-to-real pipeline.
Yeah, I will make sure to include everything that you mentioned down in the description. And also, yeah, awesome. Thank you so much again, and see you soon.
See you soon. Thanks.